All right. Hello, everyone. This is Aaron from your course. I wanted to try this OBS studio thing that I downloaded from somewhere, but this is a picture of directly from the text that I'm using. I'm using a custom edition of Business Math by Charles Miller, Stanley Salz, Salzman, and Gary Clendenen. Okay, so this is from chapter 13 on deprecation. So I'm just going to scroll through here and show you real quick what I was looking at. So basically the premise was to get students to understand how to use the straight line method of deprecation to find the amount of deprecation each year and prepare a straight line method and use the straight line method to prepare a deprecation schedule. So basically, here's the vocabulary words that our students need to understand. What is deprecation? And let me zoom this in so you can see this. I can share this in the classroom as well. So deprecation is basically, there's two types of assets, tangible and intangible. Um, it's basically when an asset loses value over time. So you all may have heard of words such as book value, like finding the book value of your car. Um, you bought it, like I bought a car in 2008. I want to know what the Kelly book value is. So these are some applications that I thought would be really good for our students to have and be able to do. So basically, the straight line method assumes, so this is an assumption, that assets lose an equal amount of value during each year of life. So that's an assumption that is being made. We don't know the actual amount that a car or anything goes down, but we can calculate that based off of the assumption. So here is some of the calculations. Um, as you can see, this one is not very difficult. So if you want to find the amount of the amount that's been deprecated, so here, let's see, this example came from the opening chapter was on capital curve and concrete. So they bought a heavy duty trailer for $14,100, and the trailer is useful for 8 years. So what? Um, let me finish reading that statement. And the salvage value is 2,100. So to get the amount deprecated, you have to take the original cost of the truck minus the salvage value, and that's going to be the amount deprecated. With the straight line method, an amount of deprecation is taken each year over 8 years. So that's going to be division. So that keyword there is division. Over means divide. So the annual depreciation for this trailer is 12,000 divided by 8. You'll get $1,500. So they're going to take that value and they're going to make a fraction out of it. So let me zoom in a little bit so you can see. So you see that 1/8. That's the amount. So you'll get a decimal. You multiply by 100, and you get 12.5, so or 12.5%. That this truck is losing over an eight-year period. So each year during the 8-year life of the trailer, an annual depreciation will be 1,500 or 1/8 of the depreciated amount. So the depreciated amount here is 12,800. The annual rate of depreciation is 12.5 or 12.5%. So if you wanted to get the 0.5, how did I get the 0.5? It's just 1 divided by 2 in your calculator and you get 0.5. But like I said, where they got this number, they took 1/8, and I can show you real quick in a, let me go here real quick. Just give me 1 second here. So we can go to Google Calculator and look at how they got these numbers. We'll just use a calculator here. So you got 1 divided by 8, and you get 0.125. You multiply that by 100 to get the percent, and you get 12.5. Now that 0.5, how did they get that fraction? They did 1 divided by 2, and that's how they got that 0.5. So in the textbook here, that's where you see that 1/2. That's where they got that 1/2 from. It was from the 0.5. Okay, now to get to the problem that I want us to do, or I want our quote unquote students to do, um, they're not finding the book value, but they're actually going to take it they're going to take it a step further. They're going to use the straight line method to prepare a depreciation schedule. So a depreciation schedule is often used to show the annual depreciation, accumulated depreciation, and book value useful, and the book value over the useful life of an asset. So an aid in comparing three of the methods of depreciation discussed in the text, the depreciation schedule of example 3 in the schedule shown for the double declining balance. You have to go back to look at 13.2, which I can show you later. But instead of reading all of that, it's best if I just show you the picture. So here's the picture. This is where I basically modified the example for our lesson. So it says Capital Curb and Concrete brought a new pickup truck for $21,500. The truck is estimated to have a useful life of 5 years. So ours was going to be 6 years. At which time it will have a salvage value of $3,500. To make the math a little bit more easier to deal with, I can do 16.6, which is, but that's going to be a repeating decimal, and what I'll do in the lesson, I'll just go ahead and change it to 5 years instead of 6 years, because you're going to get that repeating decimal. 1 over 6 is going to be 0.16666, and it's just, that might be just too much for our quote-unquote students to deal with. But anyway, it says the annual rate of depreciation is 20%. So they're going to take 1 divided by 5. So 1/5 of this truck is going down every year. They already gave them the salvage value, so they didn't have to figure that out. But they do have to determine the deprecatable amount, depreciable amount. I'm probably saying that wrong. I said it wrong, yes. Okay, so you have the original cost of the truck minus the $3,500 from the problem. That's the salvage value, equals $18,000 for the depreciable amount. Okay, this will be depreciated over a 5-year period, so that's going to be 18,000 times 20%. Where did they get 20%? All they did was this. They did 1 divided by 5.2. To get the 20%, you multiply by 100, you get 20, and you add the percent sign to it. So here they have 18,000 as the depreciable amount times 20,000. You get 36. You get 3,600. That is the amount, and here's the table that they're going to put together. This is the amount that is depreciating. This number right here is the amount that's depreciating every single year. Technically, this row does not have to be here, This column doesn't have to be here when students make their table. They can just leave it blank. At year zero, that's the year that you brought the year you bought the car, and it had a book value of $21,500. Now, where did they get these numbers? So all they're doing is they're taking 21,500. So every year it's going to go down by, it's going to be depreciating every year by 3,600. So you take 7,200 minus 3,600 and you get 3,600. 10,800 minus 7,200 is going to give us 3,600. Same thing if you do 14,000 minus 14,400 minus 10,800, and you also get 3,600. So it's going down by the same amount every year. So to get these numbers, you add this to get that 7,200 plus this to get 10,800, 10,800 plus 3,600 to get that number. See how these numbers are coming up? And then 14,000, if you take 14,400 plus 3,600, you get $18,000. So you're back at the depreciable amount. So over time, you get 21,500 minus 3,600, 17,900 minus 3,600. You get 14,300, and you keep going down. 14,300 minus 3,600, you get 10,700. 10,700 minus 3,600, you get 1,700. Every year is going down by 3,600. 7,100 minus 3,600, you get 3,500. So this is the salvage value. This number should match what they gave you at the very top here. So if when Capital Curve and Concrete want to trade in the car, they're going to get a trade-in value of only $3,500. So they've gotten a 5-year. They got a lot out of the truck. So the depreciation is 3,600 each year. The accumulated depreciation at the end of 5 years is equal to the depreciable amount, which is 18,000, and the book value at the end of 5 years is equal to the salvage value. Now, this they give a quick check in the book for you to do an exercise. Now, where does the linear function comes in? Right here. As you can see, this is a line. So as you can see, year one, you're about what it is in the table. So it's really close. It's not close to, we don't know what it really is because they're going up by 5. They're going up by 5,000 every year. So they made the table, and this is what we want our hypothetical students to do. Make a table and show the linear depreciation of this asset. And one thing that the students should have learned when they took college algebra or a pre-algebra course or intermediate algebra course is when a line is decreasing from left to right. So you start here right here on this axis, which is the y-axis. When a line is decreasing from left to right, that means you are losing value on something. If the line was increasing left to right, that means you're gaining value. So this word here, DE, means anything with the prefix D in front of it means it's going down, it's decreasing, it's losing value. So their graph, this function right here, this linear function, this linear line matches up with the data in the table. So if the students had, if we had a group of students that decided, oh, I'm going to put the years over here and I'll put the value over here, then the line most likely would have been increasing from left to right, and therefore they would have made a mistake. And at that point, I would have the students look at why is it necessary to have the years on the x-axis as opposed to the y-axis. So I would have them do some error analysis to find out why did they get this wrong. Oh, okay. So basically, that's really what we want our students to do, and I hope this video has helped you out a little bit. I'm going to post this in the classroom so you guys can see, um, can get a gist of um, why I chose this problem and how it's applicable to students who want to go into business, how a little bit of subtraction and multiplication and just dealing with percents, how that plays a role in opening a business, whether that's a brick and mortar business. In this case, is most likely a brick and mortar business because you're dealing with trucks and all. But even if you you have an online store, but you also have a brick and mortar store, you need a vehicle to get products from one place, from point A to point B, basically. So, with that being said, I want to go ahead and end this video. I hope I didn't talk too long. It looks like I talked for 17 minutes. Let me go ahead and stop. Okay, let me stop.